2014 question 2. Which of the following compounds has a giant ionic structure? So giant ionic structure. So of course, ionic compounds, they would have giant ionic structures. And so how do we know whether there are ionic compounds present or not? So usually, as I mentioned before, ionic compounds, there are two types. The first type, very common, is metal plus a non-metal. Okay. And the second type is when there are presents, they may not be metals and non-metals. This is less likely, but when there's a presence of a positive ion, a cation, and the presence of a negative ion, an anion. So, as you know, this is a positive ion, and anion stands for being a negative ion. Okay, so let's look at these options and see whether they match with the definition of us having ionic compounds. So the first one here, we have N2O4. Nitrogen, we know, is a nonmetal. Oxygen is a nonmetal as well. So nonmetal plus a nonmetal, they should be a covalent compound. Okay, so it won't have a giant ionic structure. Instead, it will have a simple molecular structure. SMS. SMS stands for simple molecular structure. How about the next one? Next one we have HNO3. So all of them, you can see H is a nonmetal, N is a nonmetal, O is a nonmetal. This is also a covalent compound. And also this would be SMS, simple molecular structure. Let's look at part C now. Part C, NCl3. Nitrogen, nonmetal. Cl here, chlorine, also a nonmetal. So nonmetal plus nonmetal, also covalent compound. So this is also simple molecular structure, SMS. So here, A is wrong, B is wrong, C is wrong, then definitely D is the answer. But let's look at D anyway. So D here we have NH4NO3. You're like, sir, N is non-metal, H is non-metal, N is non-metal, O is non-metal. All of them are non-metal, so isn't it supposed to be covalent? So here's where you get trapped. Remember, this applies to this one now. The presence of a positive ion and a negative ion. So earlier, you should be familiar with yourself to memorize certain ions, some very, very common ions. So here you can see that there is a presence of two very common ions. Ammonium ion, which is NH4+. This is ammonium ion. And there's also the other ion, which is NO3-. That is nitrate ion, nitrate ion, sorry. Nitrate ion, NO3-. This is nitrate ion. So do you see? There's a presence of a cation, which is NH4+, and a presence of an anion, which is a negative ion, NO3-. So this is actually an ionic compound, which will have the giant ionic structure, GIS. So D. But here, I want to mention one thing. So you may say, sir, then if I look at B here, let's see B here. Let me bring it down here. NaHNO3. It's nitric acid, we know that. But you're like, sir, doesn't this look like H plus and NO3-? Now, this is true. What you're saying, this could be a possibility, but how can we differentiate it then? Like when can I apply this second rule here when there's a presence of cation and anion? Because it kind of looks like here the same thing's going on. Can't you see there's an H plus and an NO3-? So here, this is where when you learn book 2C, topic 7, which is microscopic world 2, and also book 5, topic 12, patterns in the chemical world, you'll learn more about something called electronegativity. Electronegativity. So basically, if the atoms, you'll learn that they're assigned a certain electronegativity value. If the atoms, they're having a similar or sort of not such a large gap in their values, then we won't consider them to be ionic. Basically, that's the case here. But to be honest, there's only a very few examples that are following this number 2 rule, and this NH4NO3 is one of the very few examples. So here, question 2, the answer is D.